The light of awareness shines as a thread that links our inner world to the vastness of the cosmos. Consciousness isn't just what happens in the brain. It's a cosmic-scale phenomenon that reframes time, space, and meaning. In this video, we trace how awareness illuminates both neuron sparks and distant galaxies, revealing a bridge from microcosm to macrocosm. Stick around to gain a fresh lens on science and spirituality, and to learn practical ways awareness can expand how you see and act in everyday life. The light of awareness, a cosmic phenomenon. Consciousness is typically treated as a process that emerges from neural networks and sensory integration within biological organisms. Yet many thinkers explore a broader frame. The light of awareness, when viewed as a cosmic phenomenon, seeks to describe awareness as something that might extend beyond individual minds and participate in patterns that span scales, from galaxies to ecosystems. In this view, awareness is not confined to the brain. Some philosophical and scientific models propose that awareness involves integrated information, relational structure, and temporally coherent organization. Panpsychism suggests experience is a fundamental feature of matter. In practice, this yields a vast spectrum of interpretations, from micro-level proto-consciousness to a possible field-like quality of reality. The light of awareness is discussed in terms of coherence rather than mere activity. Neuroscience points to gamma oscillations and synchronized networks as correlates of conscious processing, while contemplative traditions report states of awareness that transcend time-bound tasks. Techniques like neurofeedback and meditation demonstrate practical shifts in awareness. In a cosmic frame, these internal shifts can be described as resonances that align with larger patterns of order, such as periodicities in natural systems and the rhythmic structures of space-time. The analogy helps bridge inner experience and outer structure. If the light of awareness is a cosmic phenomenon, researchers confront questions about measurement, calibration, and the very definition of observation across vast scales. Truths become relational and provisional. Experimental designs may look to cross-disciplinary indicators, from neural correlates to collective behaviors in complex systems, to map how attention and perception participate in larger wholes. Practical applications could influence inclusive design, AI alignment, and education about attention. From micro to macro, mind across scales. The brain processes signals starting at the level of ions and membranes, then builds up through microcircuits to large-scale networks that span many regions. Neurons fire in patterned bursts, and those bursts synchronize with others to form coherent activity. At the scale of the whole brain, rhythms such as oscillations coordinate attention, perception, and memory across distant areas. The idea of mind across scales rests on a chain of integration where tiny events shape vast patterns. On a social plane, minds connect in groups and communities, producing shared meanings that exceed any individual contribution. People exchange ideas, judge relevance, and align actions through conversation, collaboration, and cultural artifacts. Knowledge moves through networks of interaction, giving rise to emergent problem-solving that feels greater than the sum of its parts. In teams and organizations, routines, norms, and feedback loops tune what is noticed and what is overlooked, shaping collective awareness over time. Across scales, the same organizing logic often recurs in different guises. Self-organization, adaptivity, and attentive selection appear in neural circuits, in social networks, and in natural patterns like branching rivers or fractal outlines of coastlines. The brain's architecture exhibits scale-free properties where some nodes act as hubs, a feature echoed in other complex systems that connect distant parts through efficient routes. Fractality, patterns that repeat with similar structure at different sizes, offers a useful metaphor for how a momentary focus can reverberate through microdynamics to influence macro behavior, and vice versa. In practical terms, nurturing awareness that ripples across scales means training micro-level focus while inviting macro-level perspective. Practices that sharpen attention at the neural level can alter how networks synchronize during tasks, improving clarity and resilience. At the same time, cultivating empathy and mindfulness within groups can expand the reach of awareness, guiding collective decisions toward coherence and adaptability. Concrete demonstrations include collaborative workflows that balance local autonomy with shared goals, and educational approaches that connect individual mastery with communal understanding. The light of awareness thus travels smoothly from the smallest neural spark to the broad panorama of social and cosmic scales, illuminating how mind and world are woven together through continuous, reciprocal influence. Ontology of awareness. What consciousness is. Consciousness refers to the subjective aspect of experience, the felt presence of thinking, sensing, and intending in a first-person perspective. Ontologically, it asks what kind of thing consciousness is in the fabric of reality. Some philosophers treat it as a purely physical phenomenon arising from brain processes. Others argue that mental states harbor a non-physical dimension that cannot be reduced to neurons alone. A third stance, panpsychism, suggests that consciousness is a fundamental feature woven into the fabric of all matter. Across these views, the central questions endure. What makes a system conscious, and what would count as genuine mental life and practice? Phenomenal consciousness is the felt quality of experience, the what-it-is-like aspect of being awake to red, to sound, to warmth. It contrasts with access consciousness, which concerns information available for reasoning, planning, and reporting. For instance, we might have a vivid sensory impression without it guiding deliberate action, or we might access content without it feeling subjectively experienced in the same way. This distinction helps researchers describe cases like dream states, sensory masking, or altered states where responsiveness changes even as some content remains available to the system. Theoretical frameworks attempt to pinpoint the ontological status of consciousness. Integrated information theory proposes that consciousness corresponds to the degree of integrated information within a system, with highly interconnected networks generating richer experiential states. Global workspace theory envisions consciousness as a broadcast across a widespread network, making information globally accessible to processes that guide action. These views differ in what they count as ontologically real. IIT emphasizes intrinsic informational structure, while GWT emphasizes functional availability to a global workspace. Together, they illustrate how concrete mechanisms might ground substantial differences in what it is like to be a system. Research practice mirrors these debates by combining first-person reports, behavioral demonstrations, and neural data. The hard problem remains a touchstone. How do physical processes give rise to subjective experience? And can a non-human system ever truly be said to have a mind in the same sense we do? Neural correlates of consciousness offer a way to link brain states to reported experiences, yet they do not by themselves decide which ontological category those experiences inhabit. The ethical and practical implications follow. If consciousness is more than information processing, our assessments of animal welfare, artificial systems, and clinical conditions must reflect a deeper ontology. In the end, the debate centers on whether consciousness is an emergent feature of complex organization, a fundamental aspect of reality, or something in between, inviting ongoing exploration rather than definitive closure. Emergence and evolution. How awareness appears. Awareness begins as distributed processing across neural networks, where sensory input, memory, and expectation are integrated. When signals from vision, audition, touch, and reward are coordinated, a unitary picture can emerge from many streams. The brain's architecture supports this integration through recurrent loops, cross-area communication, and constant feedback that tests hypotheses about the world. Global workspace theory describes a stage where high-level representations become accessible to diverse cognitive subsystems, enabling attention, planning, and action to align. An everyday moment makes this concrete. A driver slows for a brake light because the relevant information is broadcast to multiple brain systems at once. Where it matters, awareness is not a single channel of sensation, but a holistic state that coordinates perception, anticipation, and intention. Evolution shapes awareness through increasing complexity of nervous systems and the ecological demands that come with social living. As neural networks grow more interconnected, organisms can compare current input with past experience and imagine possible futures. Some branches of cognition reach a level where behaviors mirror self-awareness, observed in controlled settings by recognizing actions as one's own. Primates, some cetaceans, elephants, and select birds have shown indications of such processing, suggesting awareness can evolve in multiple lineages under diverse pressures. This is not a single path. Scientific debates continue about how best to interpret these signs. Beyond biology, human-made systems display awareness-like phenomena. Complex networks show emergent properties when many agents communicate and share goals, leading to coordinated behavior that no single part could predict. Attention mechanisms in neural architectures focus processing on relevant streams. Planning and curiosity often appear as the system scales and learns. For example, a robot navigating a corridor uses memory to anticipate obstacles, and a conversational model maintains context across turns. Scholars debate whether these capacities constitute true awareness or simply functional analogs. Across biology and technology, awareness tends to surface when information processing crosses a threshold of integration and feedback. A shared representation emerges, and actions align with expectations under changing conditions. Different levels of processing form nested forms of awareness: perceptual, situational, social, and reflective or meta-awareness in advanced systems. Viewed practically, this spectrum helps researchers measure coordination, adaptability, and resilience rather than labeling a single moment of consciousness. The idea of emergence and evolution points to a universal pattern. Complexity breeds new organizing principles that appear once the network becomes sufficiently interconnected. Observation and information, the cosmic observer. Observation in astronomy turns photons, neutrinos, and gravitational waves into information that can be analyzed to reveal the workings of the cosmos. This is what the cosmic observer does. Telescopes and detectors collect light across the spectrum, translating it through instruments into precise measurements of position, brightness, and spectral features. Measurements become data. From radio dishes to infrared cameras, the signal is shaped by the instrument and the environment, and careful calibration is essential to separate signal from noise. Imaging captures spatial structure with detectors tuned to different wavelengths, reconstructing views of galaxies, star-forming regions, and the faint glow of the early universe. Ground-based and space-based facilities, from optical to radio like ALMA, provide these views. Maps are produced. Spectroscopy reveals chemical composition, temperatures, and ionization states by dispersing light into spectra and identifying characteristic lines. A single spectrum can tell a story about context, age, and environment. Time domain observations track changes in brightness and color, diagnosing supernovae, variable stars, and transient events. Variability is information. Polarization measurements map magnetic fields and scattering geometries, offering clues about dust, coherence in jets, and the structure of distant sources. Gravitational wave detectors measure tiny space-time distortions and require networks like LIGO and Virgo to locate sources and characterize their masses and spins. Signals travel across expanses of space. Neutrino observatories, such as IceCube, catch fleeting particles from energetic processes, adding another channel to observe the high-energy universe. Each channel expands what counts as evidence. Data must be calibrated, cleaned, and fused into a consistent picture using models of the instrument response, atmospheric effects, and astrophysical backgrounds. Uncertainty is acknowledged. Redshift measurements place objects in space and time, enabling distance estimates and the mapping of large-scale structure. Patterns emerge. Cosmological parameters are inferred by combining multiple probes, such as CMB observations, galaxy clustering, and standard candles. Crosschecks matter. The idea of the cosmic observer emphasizes that information gains meaning when the provenance, limitations, and context of the data are understood, not merely the raw numbers. In practice, the observer curates uncertainty and builds coherent narratives. Mind-cosmos interactions, fields, matter, and light. Consciousness arises from the brain's coordinated activity across networks of neurons and supporting cells. Neural circuits generate patterns of electrical signaling and chemical exchange that form functional fields distributed in space and time. These fields coordinate timing across distant regions, enabling integration of sensation, memory, and intention into a seamless moment of awareness. The mind-cosmos interactions begin with matter organized into complex, adaptive networks and become tangible through the fields they generate. Fields operate across scales and modalities. Local extracellular fields reflect synchronous neural activity, while long-range coupling aligns sensory processing with memory and planning. External devices can modulate these fields and reveal causal links between field dynamics and cognition. For instance, non-invasive stimulation can transiently alter cortical activity and shift perception or mood. The interplay of field patterns underpins attention, decision-making, and the feeling of continuity that links thought to action. Matter provides the substrate for all this activity. The brain's tissue is wet, dynamic, and highly organized, with membranes, ions, and signaling molecules shaping how neurons fire and how synapses strengthen or weaken. Light interacts with matter in the visual system. Photons arriving at the retina trigger photochemical changes in photoreceptors, producing electrical signals that travel through the thalamus to cortical areas responsible for recognition and awareness. Beyond vision, light influences physiology through circadian pathways. Specialized retinal cells detect ambient light to regulate hormones and timing in body systems. Light serves as both messenger and metaphor in mind-cosmos interactions. Astronomical light carries information about distant regions of the universe, and the brain decodes patterns in color, brightness, and motion to form perceptual experience. In practical terms, imaging and spectroscopy rely on light to reveal the structure of matter, while the brain uses light cues to build models of the surrounding world. The light of awareness emerges when attention and interpretation synchronize within the brain's field dynamics, enabling a conscious engagement with the cosmos that mirrors the very signals the universe uses to reveal itself. Implications for reality and meaning. Consciousness is studied across neuroscience, cognitive science, and philosophy, revealing that awareness filters sensory input, builds models, and guides action. The light of awareness reframes perception as an active process rather than a passive receipt. In practical terms, what we experience as the world is shaped by attention, memory, expectation, and the social context in which we happen to exist. When we view consciousness as a cosmic scale phenomenon, the reach of awareness feels vast, potentially extending from personal reflection to collective inquiry about matter, time, and existence. Awareness acts as a bridge between subjective sensation and external complexity, translating neural signals into meaningful patterns. In neuroscience, networks such as the default mode network and attention control circuits show how awareness can shift between self-focused and task-focused states. Reality becomes relational rather than fixed. Observations and interpretations shape how events are understood, not merely what happens. In physics, experiments show that measurements interact with systems and can influence outcomes, highlighting that observation and description are entangled. The light of awareness invites humility about certainty, because different observers may highlight different aspects of the same phenomenon. Yet the world retains structure, regularities, and causal relationships that science continues to describe and refine. Meaning arises from interpretive activity across cultures, disciplines, and personal life stories. Stories, values, rituals, and institutions organize experience into purpose and direction. As awareness is imagined to span a cosmos-sized field, individuals may feel a greater sense of belonging to a larger narrative linking ecosystems, technologies, and communities. This perspective can sharpen ethical attention to how actions ripple through other conscious beings and landscapes. It also invites plural perspectives, recognizing that diverse forms of awareness contribute to the shared tapestry of meaning. Practically, the stance nurtures mindfulness, curiosity, and responsibility in daily life. Mindfulness training can improve attention and emotional regulation, with measurable benefits in well-being. In schools, workplaces, and civic life, acknowledging awareness as a guiding force encourages reflective design, governance, and collaboration. The cosmic scale light of awareness does not dilute everyday value. It deepens it by foregrounding consequences and connection. By grounding meaning in relational context, people can align goals with long-term flourishing for both humans and the broader biosphere. Art, science, and policy all gain when inquiry remains open to the depth of awareness and to the responsibility that comes with it. Consciousness may be a cosmic scale phenomenon, not confined to a single brain, but part of a vast web that connects minds, cultures, and the universe itself. We've traced how neural processes shape experience, how contemplative and philosophical perspectives hint at a wider field of awareness, and what that could mean for how we live, learn, and relate to others. If this shift in perspective resonated with you, you're not alone. There's a shared sense of awe and responsibility that comes with it. If this sparked something, consider liking, subscribing, and sharing your thoughts in the comments about where your awareness meets the cosmos. In upcoming episodes, we'll explore practical practices to glimpse this scale in daily life, review the latest neuroscience findings, and invite voices from science, philosophy, and mindfulness to broaden the conversation. Thank you for joining this exploration. See you in the next chapter.